Hello everyone, welcome to another video on statistics, and I'm still focusing on linear regression analysis. Now in the previous video I spoke about linear regression analysis and I did a look at 1, 2, 3 points. Equation of least squares regression line, y hat is equal to b naught plus b1x, correlation coefficient small letter r, coefficient of determination capital R squared, and I'm going to add sum of squares for error today. This one leads us to what we call ANOVA, which is basically analysis of variance. So we're going to talk about this probably in the next couple of videos because this one is a very serious concept in statistics. So I want to repeat the three concepts, 1, 2, 3, and then end up with this last item here, number 4. Now, in the previous video, there was data provided in terms of x values and y values, and we had to use a calculator to determine these statistics shown here. Now, in this question, as you can see, a typical exam question, a calculator has already been used, and this information has been actually extracted from it. So we don't need to use a calculator to compute these statistics. Again, we're gonna use these in our calculation of the equation of least squares regression line and other information. So the question here says, an economist wants to determine how the number of houses called stats, denoted by Y, is affected by mortgage rates, denoted by X. And here it says a simple linear regression model was used, and the summary statistics we calculated as follows. That's the information. The coefficient of determination is, and I showed you last time that for you to determine coefficient of determination, you need coefficient of correlation or correlation coefficient. So let's start by repeating then the process we went through in the previous video, determining the equation of least squares regression line. That will be our first thing. So we have y hat equals b naught plus b1 x. And I showed you last time that this is equivalent to y equals mx plus c, and I showed you that m is actually b1 and c is actually b naught, if you remember. Now, what do we start to compute here? We have to work out b1 first. So what is the formula for b1? Well, we know that b1, if I may bring it down here, b1, for the sake of space, let me move this one here. Right, so b1, the formula says this is equal to n times the sum of all, remember this, xy minus the sum of all x multiplied by the sum of all y divided by n times the sum of all squares of x minus the sum of all squares of x, everybody or everything squared. Now, all this information, we already have it up there. So what is the value of n? Well, n is 10, as you can see here. N is 10. So we have 10 there, open brackets. Sum of all products of x and y is 12,543.4. So 12,543.4 minus sigma x, or sum of all x values, is 82. Multiplying this by sum of all y values is 1540. We're dividing this whole process by n is 10. Sum of all squares of x is, there it is, 674.56. 674.56 minus the sum of all x is 82, and we have to square this. Let's punch this then into a calculator. So what we have now is, let me move this one up. Right, what we have now is the following. When I use a calculator over here, So we have 10 times 12 5 43.4 12 5 43.4 close brackets minus 82 open bracket 82 close open 1540 close all over 10 open 674.4 sorry 0.56 close brackets minus, and I have 82 all squared. You just check if these numbers have been entered correctly. 12,543 12,543. My information is over here, I think, just to check to make sure that what I'm entering is correct. 12,543, yes, 0.4, and then we have 82 times 1540, and then 10 times 674.56 minus 82 squared. Yes, pressing the equal button, my calculator says minus 39 point. Like in the previous video, I'm going to maintain 4 decimal places. Minus 39.1667. That is the value of B1. Now I need to work out B0. Now to determine B0, if you remember from the previous video, the formula says B0 is actually equal to y bar minus B1 times x bar. And what is y bar? Well, it's the sum of all y values divided by n minus B1 times the sum of all x values divided by n. Now let's do the substitution now. So this is equal to sum of all y values from the information provided here. Sum of all y values is 1540. So I have 15 here, 40, and n is 10, minus B1 is what we calculated here, minus 39.1667 multiplied by sum of all x values, which is 82. As you can see here, sum of all x values is 82 there, divided by 10. So 82 over 10. So punching that information in the calculator, let's see what we get. What we get is 1540 all over 10 minus, open brackets, minus 39.1667 close brackets, open brackets, 82 all over 10 close brackets. The calculator says 475 475.1669 for decimal places, and then from here we are able to determine the equation of least squares regression line. Therefore y hat is equal to B0. Remember the formula says B0 plus B1 x. What does this imply? It implies y hat equals, our B0 is this one here, 475.1669 plus, remember it's minus here, so it has to be minus 39.1667x. So this is our equation of least squares regression line. Right, now let us look at the next item on the list. There is correlation coefficient or coefficient of correlation. So equation of least squares done. Correlation coefficient, remember the formula says R equals covariance divided by the standard deviation of x values multiplied by standard deviation of y values. So I need 1, 2, 3 items to compute. So covariance, the formula says 1 over n minus 1. Remember this, the sum of all xy minus, remember I'm dealing with xy, sum of all x times sum of all y divided by n. Let's perform the substitution. 1 over 10 minus 1. This information here, sum of all xy, is actually 12,543.4. That's 12,543.4 minus the sum of all x is 82 times we have here sum of all y 1540. 1540 divided by n is 10. Punching that in the calculator, let's see what we get. So let me move this one up again. Move it up like so. I'm gonna need this one at a later stage. If I move it up, this is what I'm going to get, right, so that you're able to see very clearly. All right, so we punch this information in the calculator. It's 1 over 10 minus 1. Remember, that's 1 over 9. So 1 over 9, and we'll multiply that information by 12,543.4 minus 82 times 1540 divided by 10. Closing that bracket gives us minus 9.4. So that's minus 9.4. That's our covariance. We now need this one and that one. So what does the standard, let me get a new page here. So now what we need to compute is standard deviation of x values. How do we determine that? Well, standard deviation of x values, the formula says square root of, don't forget that, 1 over n minus 1 multiplied by, remember we're dealing with x here, standard deviation of x values, the sum of all x squared minus the sum of all x, we're squaring this all over n. So we perform our substitution here. We know that n is 10, and we know that the sum of all x values, if I check here, sum of all x values squared, obviously, is 674.56. So that's 674.56 minus the sum of all x is 82, and we're squaring that all over n is 10. Let's perform the substitution into the calculator. That is square root of 1 over 9. I multiply that whole expression by 674.56 minus 82 squared all over 10. Close that bracket. What does it give us? Well, it gives us 0. I'm gonna maintain for decimal places, like I said earlier on, 0.4898, actually 99 in this case. If we round off to 4 decimal places, 0.4899. Okay, that's what we have, right? So that's our standard deviation of x values. We now need to determine standard deviation of y values. Right, so determine standard deviation of y values. Standard deviation of y values is, again, square root of, and these formula are very easy to master. The sum of all y values, squares of y values, minus sum of all y squared all over n, which is 10. Let's perform our substitution. Square root of 1 over 10 minus 1. What is the sum of all y squared? Sum of all y squared is actually 24. This is actually, let me check it. It's actually 248,400. 248,400 minus the sum of OY is 1540. We have to square that. There it is, 1540. We have to square that, so 1540 squared all over n is 10. And I have to substitute this or punch this information in the calculator. Let's see what it gives us. So we have square root of 1 over 9, open brackets, 24, 8400 minus 1540 squared all over 10. What does this give us? If we do the calculation here, it's 35.3396 for decimal places. 35.3396. 3396, yes, correct. There it is. 35.3396. That's our standard deviation of y values. Now let us work out our coefficient of correlation or correlation coefficient. Therefore, we know that R is covariance divided by standard deviation of x times standard deviation of y. Let's punch in what we know. This is minus 9.4. You can see here it is, minus 9.4. Divide that by this number, divided by 0.4899 times this number here, 35.3396. What does it say on the calculator? Well, it says the following: minus 9.4, divide this whole business by 0.4899 times 35.3396. What does the calculator say? There it is, minus 0.5429, minus 0.5429. That is correlation coefficient or coefficient of correlation. Now, our next item then is to determine what we call the coefficient of determination. If you check here, so I'm done with that item, Now I'm on the third one, coefficient of determination, which, if you remember in the previous video, I told you that coefficient of determination is basically obtained by the following formula. Coefficient of determination, if I may work it out here, coefficient of determination, I showed you last time that it's basically the square of correlation coefficient. So R, capital R squared equals small r squared. This will be equal to this number here, minus 0.5429, and I have to square this. What do I get? So minus 0.5429 squared, 0.5429 squared. The calculator says 0.2947. 0.2947. This is coefficient of determination to 4 decimal places. Now, there is one more item, but I want us to look at what this question says here. If you check here, it says coefficient of determination is, and if you look at the answer that they've got here, this one obviously is correlation coefficient, which you saw. There it is roughly. The difference on the last digit there is because of rounding off there. So our correct answer according to this question, coefficient of determination, is actually this one. The difference there on the last digit is because we rounded off the numbers here. If we did not round off the numbers, the answer would come out exactly as 0.2948. So that would be the correct answer in this case. All right. Now, let us look at what we call sum of squares for error. So there's another question here, typical exam question, based on the same data. Here it says that information, as I've already read that information at the top there, and these are the statistics. Here it says sum of squares for error is. Now, like I said, sum of squares for error, we use it in what we call analysis of variance. We will talk about that in my coming videos, but now I'm just going to explain how you compute that, because it's based on the information we've already computed. So how do we determine sum of squares for error? The answer is there. We must check which one it is. So sum of squares for error, capital S, E, or capital E, the formula says n minus 1. Again, these have to be mastered. multiply the whole of this by, check this out, the square of covariance, actually square of standard deviation of y values, which basically is known as variance of y values. So this is variance of y values, and then we must subtract from this the square of covariance divided by the variance of x values, like so. And you can see that these have already been computed. So now if we substitute, what is our n? Well, n is 10 minus 1. And then we say the variance of y values. We know standard deviation of y values. If I check here, standard deviation of y values is 35.3396. We just have to square this. So it's 35.3396 squared minus covariance. If you check, covariance is basically this one here. There it is. It's minus 9.4. We have to square that. So minus 9.4 squared all over variance of x values, which is the square of standard deviation of x values. Where is it? There it is. That's the standard deviation of x values. We have to square that to get variance of x values. So 0.4899, and we have to square that. Let's see if what we get here is going to be one of the options provided on this question here. If it's going to be one of the options provided there. So here is our calculator again. We have 9, open brackets, that's 9, open brackets, 35.3396. We square that. And then we say minus, open brackets, they up, minus 9.4, and we square that all over 0.4899, and we square that. Let's close the bracket there. What's our final solution? Well, our final solution is 7926.51 37 4 decimal places. Now let's look at the options provided. You can clearly see this is 7926.5137. If you check, this is out 7962, but here we're saying 7926, so that's out. This one obviously is out, that is out, that is out. Check the last one there, 7926.5, and here we have 7926.5137. If we round off this to one decimal place, it's actually going to be that one there. That's the sum of squares for error, which you will see its importance when I start talking about analysis of variance. All right, this is where I'm going to stop for today. I love statistics. I don't know about you, but my my love for statistics is just as strong as my love for maths and physics. All right, I'll see you next time.